All right, page 4, we're just gonna start there, and then we're gonna do hopefully some fun graphing on our calculators. That's what I would like to do. Um, First glance, right away, right off the top, this would be not general, right? No brackets. So I'm looking for brackets tell me it's not general, so you have to treat it a little differently, and it's just good to be able to identify that right off the top. And I think I'm just going to focus on the non-generals here. The key is posted, right? So here in this case, A is actually right in front here. That's where A is located. It's always at the front. Sometimes it's visible, sometimes it's invisible. So in this case, there's a 1 there, right? So opening, A is positive, so it'd be opening up. A is equal to 1, so this would be considered a normal. The width is normal, right? It's not super narrow, it's not wide. This is what we would consider right down. So that's like our baseline. And then the y-intercept is not -7. Grab your calculators if you have it ready, and let's type that in. So I use my brackets, right? I go x minus 4 squared, take away 7, right? It's all minus. No need to press the negative in this case, okay? You only use the negative at the very beginning if that coefficient is negative. Other than that, you don't use negative. So if you type this in, you hit graph. In this case, I can see it fairly well. I don't know if zoom standard is always that's always going to be my reset button for my window, because you're going to notice we're going to change this dramatically. We're going to change this window like in every way possible. So zoom 6 gets you back to what I'm seeing right now. Okay, so to find the y-intercept, it's second trace value. So basically, it's asking you, hey, give me an x value, and I will spit the y value back to you. That's basically what it's saying. So when it's a y-intercept, we know that x is equal to 0. We hit enter, and watch, you see that it's 9, right? 0, 9. So I'm going to say that it's 0, 9, and I went second trace value, x is equal to 0, right? That's what I did to come up with the coordinate of the y-intercept. So it's not -7. You notice that, right? Everything else, it's basically the constant at the back, right? But not that one. So let's do this one here on the end. Let's type this one in. So I want to block this for you here. But let's go ahead and do that. Clear whatever is on there. And then watch how I do. Be careful with fractions as your coefficient. I actually do this. Watch. Bracket -1 divided by 3 close bracket. That's what I would do. That is a -3rd right there. And then I go bracket x minus 4 close bracket, and then that last term, which is x plus 5. And then you hit graph. Did we know it's going to point down? We did know that, right? We did know that because it's negative, right? This is A. So we did know that A is negative, so this will be pointing down. So we predicted that already. This is the tricky one. Students are like, oh, it's negative, so it's obviously wide. No. Just look at the value of A. A is just without the sign, A is between 0 and 1. So this would be wide. This would be considered a wide curve. And the y-intercept, let's go ahead and find it. Second trace 1, x is equal to 0. And there it is. It's a coordinate. It's 0, 6.67. And let's put down what we did, right? Second trace value x is equal to 0. That's how we did to figure that out. I'll do one more. This one. It's in general form because there's no brackets there. Where is a located here? It's actually right here with sign and everything. This is a. It's in front of the x squared term in this case. A is positive, so this will be pointing up. The width, a is greater than 1, so this would be a narrow curve. And my y-intercept? It's actually this one right here. This is c. It's the constant. It's just without a variable attached to it. So that'd be -7. So it's 0, -7. Let's double check that. I want you to get really good at typing stuff into your calculator, okay? So let's go y equals, clear whatever is there. Type it in exactly the way you see it. 0.8x. Take away 7 plus 10.5 x squared. Hit graph. You can tell it's kind of narrow, right? It was a little, it's narrower than what we had before. Let's find the y-intercept, okay? Just to make sure Mr. Dirksen isn't just feeding us some wrong information, right? So second trace 1, x is equal to 0. See, it's -7, right? Right there. So there we go. No need to use second trace for that one. Okay. All right. Let's keep going. The whole thing is on the key. I can't go over the whole thing, but I thought I would do this. Okay. Let's keep going. I think I kind of stopped with the weird equation of the axis of symmetry and the equation of the max and the min. To be honest, once you have your vertex, it's very easy to come up with them. I think what students do wrong is they're like, oh, axis of symmetry, 2, 0, because it's 2, right? No, it's an equation of the line that cuts it in half. That's the axis of symmetry. And the min or the max, it depends on which way it's pointing. If it's pointing down, then there's a max. So the equation of the max is y equals to 3, right? If it's pointing up, there is a min, right? So this equation would be -3.5 in this case. Why? Because the y value of the vertex is -3.5. Both of them cut through the vertex, okay? Let's keep going. X-intercepts. I'm going to tell you this. It can have up to 2 x-intercepts. So here we go. I'll show you this using Desmos. It's a free website. You can go desmos.com and do exactly what I'm doing here. Right now, this parabola has no x-intercepts. You see that? But if I were to change, C is the one that shifts the whole thing up and down. But if I were to shift it to 0 right there, there's actually right now 1 x-intercept exactly. But if you were to shift it even further down, how many x-intercepts do you have now? There's 2 there, right? So a parabola can have none, it can have 1, or it can have 2. Right? Hey, let's do it the other way. What if it's pointing down, right? It has no x-intercepts. In this case, it would have exactly 1. I'm going to try that. I can't. Anyways, you get the point. And then this is 2 there, right? So the exponent of a polynomial. What is a polynomial? This is many terms. The exponent tells you how many x-intercepts there are possible, right? For a linear, the exponent is 1. You have 1 x-intercept. For a parabola, the exponent is 2. The degree is 2. You can have up to 2. For a cubic, next year up to 3. Okay, so that's how it's gonna go. Okay, here we go. The 7th characteristic would be the x-intercepts. And I'm going to highlight this, that I just mentioned that. The degree of the function tells you how many x-intercepts are possible. Here are the 3 possible scenarios. So you can have, let's just make a scenario here. If you have a different color, it doesn't matter, right? This would be no x-intercepts. So it could be pointing up like that, or let's put the other one here. Right? So there's the vertex. That's like the turning point. Right? So there, in that case, you'd have no x-intercepts. Then there's a scenario where you have exactly one. Exactly one. That means that your vertex, if you follow my train of thought here, the vertex has to be exactly on the x-axis. Right? So it's either like this, and then it goes up like that. My trick is to go to the vertex and make it look symmetric as possible. Let's shift over to the left a little bit, somewhere on the left side of the x-axis. Put a dot right on the x-axis and just do this. Okay. That would be exactly one x-intercept. And then, of course, you guessed it. Let's say we have our vertex down here, and we know this is pointing up like that. There, it's happening twice. Okay. It's happening once there and once there. Same as scenario if it's pointing down, like if the vertex is up and your parabola is pointing down. So there are your 3 scenarios, and I'm going to describe them a little bit. So everything has to do with the vertex and which way it's pointing. Okay, vertex, which way is it pointing? Okay, so vertex is above x-axis, right? And points up. A is positive, of course. On the other hand, it could be that the vertex is below x-axis and points down, which means that A is negative, right? That's that scenario. I'm saying when it's one x-intercept, the vertex is on the x-axis. And I will say this, sine of A is irrelevant. Right? It doesn't matter which way it's pointing. If the vertex is right on the x-axis, that's the only x-intercept. So which way it's pointing, it doesn't matter. Okay. I will say this on the bottom here. I'll just make a note. The vertex is also the x-intercept. Right? That's a big note here. I'm just going to put that in like a cloud. In this case, your vertex is also your x-intercept, right? So it's two things. And you'll see sometimes that there's an overlap, that one of the intercepts happens to be a key characteristic of the parabola as well. And then here, to have two x-intercepts, you need this, vertex above x-axis and points down. Or vertex below x-axis and points up. How do you know the vertex is above or below the x-axis? What value of the coordinate would you be looking at, the x or the y? The y, right? So don't tell me if the vertex is positive. Tell me if the y value of the vertex is positive, you know it's above, right? I don't want to make this too busy, right? But in this case, right, the vertex would be x negative y, right? In this case, the vertex would be x positive y. Let's do this one here. X positive y. I say I don't want to make it too busy, and I go right ahead and do it, right? Yeah. Hypocrite. I'm trying to help you as best as I can. And I think I'm going to skip the next part that is below this. I have a reason for it. I'm going to go straight to the meat and potatoes of today's lesson. So what have we just done now, guys? Okay, all right. We've just basically described the characteristics of a parabola, right? All these different things. Let's go over to page 7 and domain and range. I know some of you probably have nightmares right about now. Like, no, I hated domain and range. Chapter 5, I'm scarred for life. I'm going to try to make it a little less painful, but I think practice is key. Practice is all you need, okay? All right, so here we go. Domain and range of a quadratic function. Watch this. This is very important. What does non-contextual graphs mean? What does that mean? No word problems, okay? No word problems. Once we do word problems, this will change, okay? Once we do word problems, this is not going to be quite the same anymore. It's going to change. So if you have two different colors, I have, what am I going to use? Orange. No, actually, what? Two different colors. That's all I'm going to say. I have pink and green. I'm going to stick with that. That's what my... Okay. Domain refers to all permissible x values. Domain, x values that are acceptable. Set notation, x is part of the real numbers, right? This is reads, right? X is part of the real number set. Okay, and real numbers is just everything, positive, negatives, integers, decimals, fractions, anything, right? So real numbers is just everything goes, basically. There's no restriction on that. Interval note, so there's something we call set notation, and then we call something interval notation. So the interval notation kind of has the start and the end. So for us, it would mean negative infinity to positive infinity. Okay, that's how you would do interval notation. I will never make you do one over the other, but I might give you a domain and you have to be able to read it and understand, right? Okay, these are saying the exact same thing, just in a slightly different way. All right. I like interval notation. Later on, I'll show you that. Range refers to all permissible y values. Okay. So how about we do this? I'm gonna go pink here for domain, and I'm gonna go green for range. The screen is a little dark, so I'm gonna do different green this green here. Okay, so when it comes to domain, right, you look at this graph and the arrows tell you that this keeps on opening up indefinitely. So in this case, there's like arrowheads going from left to right. So it would be all the way to negative infinity, all the way to positive infinity, right? Same thing here. This graph that is pointing down, your domain would be talking about all the values there. You know what? Let's go negative infinity here to positive infinity there. Doesn't hurt. Negative infinity, so all the way as far left as you can possibly go, and as far right as you can possibly go. I know we don't deal with infinity very well, right? It's so abstract. The range in this, look at how range will change. It rhymes and everything. It's poetry month after all. Right? Range starts here and then it goes up. Okay? And then again, over here for this graph, range, this is like if you go like this, your cup empty and then full, right? Goes up to here, but then it only goes down from there. Okay? So in this case, watch this. This would be a number, and this would be positive infinity. When it comes to your range here, it would be a number down here. It wouldn't be infinity all the way to infinity. And here, it would also be a number all the way to negative infinity as well. Right, so this is regarding the range. Okay. So I need to clarify range here, because domain is going to be the same for now. It's always going to be this. Range is a little different, so watch here. If you want to go set notation always needs to have the squiggly brackets, I call them. I don't know what the official name is, so I'm just going to call them squiggly brackets. Right? So for set notation, you're going to go like this. When it's this scenario here, and remember that this dot here represents the vertex, which is x, y, right? It's a specific point. Same with this one up here. Let's do the same thing. Vertex, and it has coordinates x, y. When it comes to the range for this particular graph, you would say y, the y values are only applicable if they are greater than or equal to this y value here. Y value of vertex. And then close with a squiggly bracket like that. You're gonna lose marks if you use round brackets when it's set notation, okay? Let's do this. Let's do the same thing for this scenario here. You go squiggly brackets, y. The y values are only applicable if they are less than or equal to this y value up here. So the y value of vertex. So I don't know if on your study sheet, on your cheat sheet, you might want to do like, hey, this is what the symbol will look like when it's pointing up. And this is what the symbol will look like when it's pointing down. I don't know. I'm just giving you ideas, right? What do I know? Interval notation is different. Interval notation, when it's going up like that, you'll have the y value of vertex. I will just go y value vertex, okay, not of. Okay. Y value vertex all the way to infinity. And infinity cannot be included, so you have to have a round bracket. On the other hand, if it's pointing down, you're going to go from negative infinity all the way to the highest number, which is going to be the y value of the vertex. I hope this rings a bit of a bell. Infinity cannot have a square bracket. And I will give you another note here. Note. For smallest first, right? Smallest, then largest. Always like that. And I will not put brackets around it because then you're going to be like, oh, it's always square brackets. It's always round brackets. Not necessarily. It depends on the situation. So example, some students, they say, hey, this one goes from, I'm trying to think the mistakes that, let's say this. Let's put square brackets on both. Other than infinity, you're not going to have to worry about round brackets. What's wrong with that? Smallest would be -2, right? So you got the values right, but they're not in order. So this is wrong, okay? You got to go, the smallest number in this case is -2, the greatest is 5. This is correct, okay? Or some students will go and say 7, negative infinity. Which one is the smallest out of the two? Well, infinity is really big, Mr. Jackson. I know, but negative infinity is as small as you can possibly get. So this is wrong. You got to go negative infinity first, all the way to 7 positive, like that. That is correct. Because this is the smallest here. Okay. So smallest first, then largest second. All of this just to review domain and range, right? Okay, we'll practice that on the next page here. Okay. Okay, so I'm going to tell you this. Assume there are arrowheads everywhere. X, Y. Okay. Same with the bottom one. Arrowheads on the axes as well. X, Y. Okay. Perfect. I want you to do the domain. I want you to do the range. Let's cheat here and do the domain for both of them already. Easy. Easy. Get that one out of the way. Same with this one down here. We're not given any indication that this thing stops. So the domain is not going to be your biggest issue at the beginning for non-contextual. That's it. That's done. But the range is. The range is going to throw you off a little bit. So that's where a good study sheet is going to help you out. But let's put it this way. The range, we're going to stay with green here. Technically, if you match this to the y-axis right here, it's everything from there and lower, right? For that one there. So for set notation, squiggly brackets, this would have to be y is less than or equal to the y value of the vertex. So in this case, it is a, right, 3 decimals. Why? Just take it. Just take it as is. So you're saying that anything below this number, it could be exactly 2.749, but it has to be anything less than that, and you would still see a curve if you look to your left, right? But if you go above it in any way, shape, or form, you're not going to see a graph anymore. It doesn't exist there. All right, let's do another one here. Interval notation. I know it's something with negative infinity. I have a feeling, right? Negative infinity here. So negative infinity is first, all the way up to 2.749. That number is included. Infinity is not included. Can you do the range for the bottom one there? You have to figure out the coordinates, as you can tell. Figure out the range on your own. Take the risk. See if you remember from IPR. Ready? Drum roll. No coordinates of the vertex, but it's key, right? So this right there is 5, 1, based on the scale that I see here. 1, 2, 3, 4, 5, right? Goes up at 1. So that's, I'm focused on that. Set notation. It's pointing up. So the y values would have to be greater than or equal to 1. And if you want to use set notation, you're going from 1 to positive infinity. So this is round, this is square. And I will do the marker here, right? I'm going to trace this down to my y-axis, put a dot there, and say that anything above it is included in my range, right? I didn't do the range, right? So, but you can tell yourself, right, this is pointing up. So yeah, of course, anything 1 or greater works. This is also saying 1 or greater, right? 1 all the way to positive infinity. I thought I had added some more practice, but it is what it is. Yep. Did I? This one here? Because you always read it from right, left to right, just like you read a book, right? So here you're saying y is greater than, right? This is greater than whatever that value is. And this would be, so are you saying this one should be less than? No, ask. I want to clarify if there's. Here I had to use. Okay. No, make sure you ask. Don't feel bad. We're good? All right, thank you. Meat and potatoes are coming. All right. 9 is where it looks scary, but I think you're gonna be pros at graphing by the time we're done with grade 11 applied. And when you go to grade 12, and there's a big chance you'll have Miss Yosik, you'll be like, I know how to graph with my eyes closed. It's like, just give me a piece of paper, right? You'll be pros at it. So that's my goal, okay? So I want to make a very quick note here. This is gonna happen to you, so you gotta watch out. If you ever see something like this, if you see e to the negative 7, 8, 11, it doesn't matter. We consider it 0. We would not write down, don't for sure not write down 5.71. That's for sure not right. It's the equivalent, if you're taking chemistry or anything like that, it's the equivalent of saying this times 10 to the power of negative 7, which is a very, very small number, right? We don't consider that. We would consider that 0, okay? So if that ever happens to you, be warned. Sometimes the calculator tries to be so precise that it will give you this. We don't worry about it. Okay, let's start here. First of all, I want you to know this. The value A is negative 0.5, right? A is negative 0.5. B is what? It's positive 25 right here. C is negative 200. So if I ever ask you what are the values of A, B, and C, you go and get them. Look at the variable. The highest power is your A, your leading coefficient. X in this case is your whatever's in front of it is B, and C is the constant. And if there is no constant, guys, C is equal to 0. It's not, don't say not applicable, it's just 0. Okay. Okay. So this is, you would have to agree with me, this is in general form. Whether you disagree or agree, you have to agree with me today. There are no brackets, right? Opening, well, A is negative, so this will be down. Soon you won't have to do all of this, but I still need you to do this. Width, it's A is between 0 and 1, so this is actually a wider curve. Y-intercept, vertex, all of that fun stuff. We're going to do that now. Okay, grab your calculators. Go hit y equals and type this in. I'm going to clear whatever's on my screen. You got to go negative, not minus. Negative 0.5x squared plus 25x minus 200. Do we know our y-intercept before we graph it? Do we know our y-intercept? It's 0c, right? So this would be 0, negative 200. Let's write that down before we graph it. So now, are you ready for this? This is going to be a bit more work, okay? So hit graph. There's a chance you won't see anything. Oh, you see a sliver? This is where the window comes in. That's where you knowing what's happening is very important. Picture this with me, okay? If you see this, would you agree with me that right now the graph is like this, right? This is just the leg on the left side, okay? So watch what we're gonna do, guys. You're gonna press window. When you press window, Miss Yosik or whoever teaches you next year may not do this, but I only touch X min, X max, Y min, Y max. Those are the only 4 things that I touch. X min, let's write this down. This would be your X min here. Like that's telling the calculator, show me all the way up to here. Then you go X max on the right side for now. Up here, you're going to have Y max. And down here, you're going to have Y min. That's what these parameters do. Okay, they make you see more. So we're gonna change our X max for now. So I'm gonna try things. I don't know the answer, by the way. I'm just gonna try 100. X max, change that to 100. Then hit graph. Do we see both legs now? Perfect. Did we overkill it? Did we do too much? A little bit, right? If this is 100, then 50 is right about there. So we overdid it. Does it matter? It doesn't matter. But I'm going to go back to my window and change it to 50. X max back to 50 because I want you to have a nice view of it. Okay? Hit graph again. That's not bad, right? We know that where is the vertex, above or below the x-axis? Let's see. This is pointing down, right? Meaning the vertex is somewhere up here, right? So we got to go back to our window and change our Y max. Y max. Okay. What are we going to change it to? I'm going to go 100. You're going to be a lot faster after a while. You're going to go whatever, 1,000. I'm going to go 1,000, 10,000, whatever. I'm almost there. So let's go back to our window and go 150 maybe. It doesn't matter if you pick 200. It actually doesn't matter if you pick 300, but it makes it harder to see it. You're looking at the same curve. I'm standing closer. You might be standing farther away, but we're looking at the exact same curve. All right, guys? So don't panic if yours doesn't always look exactly like my screen if you picked a different window. This is pretty good. There's one thing missing. I want to see all the intercepts. Am I seeing the y-intercept right now? No. Do I know where it is? Look at where my finger is. So we're going to go window. What are we going to change? Yeah. Y-min. That's right. What should we change it to? Let's go 250, like not exactly bang on 200. We're going to go a little lower. Minus 225, minus 250, negative. Okay, negative, not minus. Sorry, my bad. Because you're going to get an error if you use minus. Hit graph again. That's a pretty good graph. I'm seeing x-intercepts and the y-intercept, and I see my vertex. That's all I need to graph. That's perfect. Let's say you make a mistake. You're all over the place. You have no idea where this thing is. You're going to go like, don't do this right now. I'm just going to show you. I'm going to go zoom 6. I'm going to start from scratch, and then I'm going to make my changes, right? No, this was 50, right? Y min was negative 250. Y max, was it 100? No, 150. There. And now it's back, right? So, because sometimes you make a mistake and it throws everything off. Go zoom 6. What does zoom 6 do? It's a standard window of negative 10, 10, and then it's negative 10, 10. Like it's just like a 10 by 10 window. That's what zoom standard does. All right. Are we all seeing this, guys? Please let me know if you're not seeing this. I don't want you to be like lost. Because at first sometimes it happens, right? Let's find the vertex. But before we do that, I'll tell you how to find it. You got to go second, trace. Is this a min or a max right now, the vertex? It's the highest point, right? So in this case, it's a max. So let's go ahead and do that. Follow me. Second, trace. You see maximum, right? Fourth option, hit enter. Look at what it says at the bottom here. It says, give me a left boundary, meaning we know the vertex is there. The calculator is saying, give me a point to the left of it. Any point, doesn't matter. So you would use your arrows, left and right arrows, to move the cursor. Are you to the left right now? You may not be. You may be over here somewhere. You might not even see your cursor. Go by the coordinates that you see on your screen as you're moving it. Watch. Let's say mine is completely out of the screen right now. I can't see it. Mr. Dirksen, I have a problem. You look at your coordinates. As I'm going left, I see the y value. It's coming up. Right? Oh, there it is. So now I'm going to bring it all the way to the left of the top. So is that okay? Yes. Is that okay? Yes. How about there, Mr. Dirksen? How about there? Yes. The answer is yes. Anywhere to the left. Okay? Hit enter. What is it asking now? Right boundary. So you're going to go over the top of the hill and you're going to pick a point that is to the right of the vertex. So go arrow to the right and then hit enter again. And so now you told the calculator the vertex is anywhere between here and here, go and find it. Okay? You know how it says guess? It's always going to do that. It's just waiting for you to tell it to start. So you hit enter. And there's the maximum. That's your vertex. So write down the coordinates. In this case, it's perfectly 25. If there are decimals, you write them down, okay? 2 decimals always, 2 decimals, all right? We're good. This is the first thing I would like you to find if possible. Next. I think we're going to have enough time. Skip. This is the next one I want you to find, the x-intercept. Very important. This is how I do it. I do it this way. You're going to go y2 is equal to 0. And then you're going to go second, trace, intercept. You got that? Y2 is equal to 0. Then you're going to go second, trace, intersect. Intersect. So let's try that. And that's why these calculators are awesome, because they have different colors for every line you graph. So you go to y equals, press y equals. You go to the second y, and you just type in 0 there. Then hit graph. You see that? It's a horizontal line across the x-axis. You see that? So we're now going to go second, trace, intersect. The fifth option, you can press 5 or you can go down to 5 and hit enter. And this is how this one works, guys. First curve, you're on the blue. You got to go as close as possible to the intersection you want to find. That's good enough. You don't have to be right on it, just closer to the one you want. Then hit enter 3 times. Count with me. Enter, enter, enter. And there's that x-intercept, the first one. What is it? 10, 0? It should be 10, 0. Is there another one? Yeah, Mr. Dirksen, obviously, I can see it, right? Second, trace 5 again. Second, trace 5. you're going to go all the way over to the other one you want to find. I don't care which one you find first, to be honest. And you're going to hit enter, enter, enter. Why is he so slow, right? 40-0, because I know, don't feel bad if you're a bit lost today. Like, it's okay. I just want you to practice. When you go home today, you're going to practice, okay? So that's that. Could we have used the calculator to find the y-intercept? Yes. Do this with me. Second trace 1. I know I'm almost out of time. I know that. X is equal to what when it's the y-intercept? 0, right? Negative 200. We knew that already, right? But it's just nice to be assured. Mr. Dixon, what if I'm a rebel and I type in 50 for X? What if I type in 50 and not 0? Watch. It shows you the one over on the other side. You can type in anything you want for X. You can go 12.85. And it will give you the Y value that's associated with that X value. Isn't that cool? So it's like any X value you put in, it will spit back the Y value. It will come in handy later, trust me. Let's finish the rest of this here. What's the axis of symmetry? It's an equation, right? And it is the X value of the vertex. It's a vertical line that cuts it in half. Is it the equation of min or max? It can't be both. It's either or. In this case, it's a max, right? That'd be y is equal to 112.5. That's a horizontal line like this. What's the domain and range? Domain, I'm glad you asked. I love domain for now. Later, you might change your mind. I'm going to give you both versions, Mr. Dirksen, just in case. Don't want to lose any marks now, right? And the range, 10, 10, 10, right? Which way is it pointing? It's down, so it's less than or equal to the y value of the vertex, 112.5. This is going to be a lot easier once you graph this thing. Or you can go negative infinity all the way up to 112.5. Square brackets, round brackets. Okay, your homework is to do the next 2 pages. What is it, 10? I would like you to graph, but I'm going to say hold off on graphing. I'll show you how to do that, like on paper. So just fill in the tables, okay? Make sure you do that. Make sure you do that, okay? So what is it? Homework is 10 and 11? Yeah, pages 10 and 11, just 2 pages. Have a good day, guys.